Hello everyone. This video is about my experience of changing different components using hot air gun and soldering iron. I want to show you how I remove, place and change components. What I do is not law, it's just what I do. Everyone has their own method. And they're sure of their methods. And I did that and it works. Hope you find this content useful. First, let me show you what tools I use. And then show you how to remove different components. These are my hot air gun and soldering iron. I use Gordak 952, which you can find in any repair shops. And the soldering iron tip that I use is sharp bent tip. And the soldering flux is Amtech. So those were the stuff I needed to mention first. Now let's go see what's next. I'll start from simple components, then I'll talk about the more complex ones, which are I/O and different slots. Make sure to apply Amtech soldering flux before starting to remove components. Because as you see, it decreases the melting point of tin. I'll remove the component by using sharp bent tip tweezers. As an example, I removed as a capacitor. It can be resistor, inductor or any other small components. As you see, I'm grabbing the end of the tweezers. And as it has bent tip, it's easier to work with. The important tip is that the ends need to meet and be flat. If the ends are crooked, the component will be thrown when you want to take it and will be lost. So try to use high-quality tweezers with sharp ends which meet. The next component is inductor. Repairmen have different methods to remove them. The method I use is to use soldering iron. As you see, I renew solder of two sides of the inductor and heat with soldering iron and remove the inductor from the circuit. There are repairmen who use hot air gun for that purpose, which I also show you. As you see, you need to be patient and remove it slowly. If you put too much pressure, PCB might get damaged, or inductor might get broken. So make sure to try to be a little bit patient. The next method is to use hot air gun to remove components. A disadvantage of this method is that it burns or changes the color of ferrite on inductors. It might damage the inductors itself as well. But change in appearance is the reason why I don't use this method. Now by putting the two inductors next to each other, you can easily see the physical difference between them. One is removed by soldering iron and one is removed by hot air gun. Removing and placing an inductor by a hot air gun, or heating it too much, might damage the internal inductor, or might break or damage its ferrite, which happens sometimes due to high heat and by putting too much pressure on tweezers. To place them, you can use hot air gun or soldering iron. Hot air gun is an easier option to place them, because solder under the inductors was melted once and then was renewed. You can place the inductor by hot air gun more easily, and also heat it less. I'll do it by soldering iron too. And as you see, it's not so clean. Let me heat a bit by a hot air gun. As you see, tin melts and inductor gets loose, and it gets placed on PCB correctly. The next components that we frequently change are different types ICs. This one has pins on its sides, meaning it's not BGA and it doesn't have balls under it. I apply Amtech soldering flux and heat it in rotation. Because if you don't move the tip of hot air gun, it would definitely damage IC. Make sure to rotate it while heating a component, so that heat would spread evenly on the IC, and tins would melt faster. Then remove the IC. After removing the IC, I'll resolder the pins with Amtech soldering flux, so that all pins would look similar. Because when I wanted to place the IC, tin would stick to IC pins. The next tip is where IC is pointing to. There is a mark on one corner of the IC or on its back. As you see, 3 corners are sharp, one is not. The one that's not sharp is pin 1 of IC, which is on the other side of the IC, and you need to place the IC according to the mark on PCB. And to place the IC, you need to spread the heat evenly on the IC by rotating the hot air gun. Make sure to set a heat suitable to your own working speed, because some work slowly, which damages the PCB if it's too hot. After placing the component, and before the device cools down, I always clean the PCB with thinner 20,000 or quick dry thinner. As you see, pins are properly placed on the board. An important point while cleaning is that, when you heat the component, and while PCB is hot, components might melt. So, make sure to spray the thinner first and then clean it with a toothbrush, so that it cools down and components wouldn't get detached from the board. The next component is a microswitch. And as it's a plastic microswitch, I'll show you how to remove and place it too. If it's damaged, you can heat it with a hot air gun and remove it. But if it's working, meaning if you want to remove and place it from another board, it's better to heat the microswitch from the bottom until its pins melt. As you see, I already applied Amtech soldering flux. And after heating from the bottom, try to move the microswitch slowly from the sides. As you see, when it moved, it means that tin is melted, and you can quickly remove it. And to place it, if there is no component on the back of the PCB, you can heat it from the back and place the microswitch. As I want to do this by a soldering iron, I'll clean pads under microswitch by desoldering wire first, to have a smooth surface. And then I'll place the microswitch. And always make sure to use Amtech soldering flux. Because it causes the component to attach to the board without moving too much. This way you can solder or heat it easier. As you see, I'm holding and moving the component with tweezers. There is a copper part here, and as my soldering iron tip is too big, it touches it. This is a horseshoe soldering iron tip. But for smaller components, I use sharp bent tip. I use two types of solder wires. Mechanic soldering wire 0.3 and Asahi soldering wire 0.8. I use mechanic soldering wire 0.3 for these small ones. As you see, I am melting soldering wire. And solder the pins. As you see, it's properly placed, and it is working normally. Always make sure to work clean. Next thing I want to remove is a connector. I don't exactly know for what is, but I'm going to show you how to change it. I'll heat it from the bottom like microswitch, so that it won't get damaged. But if you want to remove the connector and place a new one, you can heat it from the top. That way, the plastic would melt and you would be able to remove it faster. But I'll heat it from the bottom, as I need this connector and want to place it back again. And as I showed you with microswitch, this plastic connector can easily be removed from the board too. Now let's see how to place it. Again, as I showed with microswitch, I'll clean PCB pads under the connector, so there wouldn't be any tin, because that causes connector to get placed on PCB easily and more accurate. Then you can start soldering. I apply Amtech soldering flux and place the connector on the PCB. And try to adjust it. Try to solder connectors holders first. Meaning, first solder the holder pins of connector to PCB so that the places of the pins could be obvious. Then start soldering connector pins to PCB. I'll solder two sides of connector holders so that connector doesn't move or shake. And I'll start soldering the pins. The important point to know about plastic components is that you shouldn't hold the soldering iron on top of the pins, because plastic would melt that way and the pin would get deformed. And that would damage the connector. You need to solder them one by one. You need to be patient and also accurate. In order to have a nice result. If you hold the soldering iron for too much, the plastic connector would melt. Wherever I feel it is not placed accurately, I'll use Amtech flux so that tin would be spread on pad and the pins, and connecting them together correctly. As you see, the connector is soldered to PCB perfectly. And to test it, you can drag a needle or anything needle-like on pins and check if pins are connected or not. This one is small, but I'll show you how to do it with an I/O in the following. You can also do it with the tip of tweezers. One of the most difficult components to change is I/O. And as it has 128 pins, I should say that the easiest way is using BGA machine. But those who don't have that can use hot air gun for that purpose. First I use soldering flux, as always. I apply it on four corners of I/O. And as you see, you need to move the hot air gun to top of I/O pins in circulation. As I said, don't point the hot air gun directly on top of any components. Always move it, in order for the component PCB not to get damaged. As you see, it can be removed from the board easily. Some repairmen heat the PCB directly, which causes it to be swollen. That causes PCB to get out of order, because the layers would be separated from each other. and all the connected parts would be disconnected. So make sure to move the hot air gun in circulation. What I'll do next is to remove 10 of the pins to have a smooth surface. Try to do it delicately and with high accuracy, because if you put too much pressure on PCB by soldering iron, the pads might get removed from it. So try to be gentle with it until the tin gets removed from the pads and have a smooth surface. It's finished. I'll clean the board now to remove the grease and clean the burned soldering flux and dry it with a napkin after spraying thinner. And I apply soldering flux on the pins again. I captured the rest under a microscope. This way it could be easier to see it. I'm sorry for the low image quality. I place I/O on the board and fixate the pins approximately. The first pin of I/O is marked with a small circle. You can see on PCB 2. This is pin 1. I place it on the board. I'll zoom in to be able to see soldering process better. First I'll start soldering the corners. And as I am right-handed, I'll go with left corners so that IOIC won't move. And tin needed for the pins will be accumulated here, which I'll use to solder the rest of the pins. You'll see that in the following. I'll apply a little bit of tin on all 4 corners. The more you do it, you'll realize how much tin to use, so that it wouldn't be so much or so little. If you apply extra tin, you would need to remove it from the board. After soldering 4 corners, before starting to solder each side, I need to apply soldering flux. The tip of my soldering iron is bent, so it's easier for this. I start from the part 1 applied tin and drag soldering iron on the pins in a steady way, and so slow and gentle, without damaging or bending any pins. and spread the melted tin on all over the pins. And as I applied soldering flux, the pins attach to PCB more easily and pins get disconnected from each other. If you see some pins sticking to each other, as you see, you can separate them by dragging soldering iron tip from up to down. Let's solder pins of another side to the board. Exactly like the previous side. Some repairmen use hot air gun to place I/O. And they don't clean the pins and heat the I/O with hot air gun when they place it on board. It's an easy method. You might get a nice result if you get the hang of it. But as I/O gets heated too much to be attached to the board, the I/O or PCB would most probably be damaged. Because you heat the PCB once, to remove I/O. And if you want to heat the I/O again, to solder it back, PCB would most probably get damaged. Especially when you remove the I/O from a scrap board and I/O is not new. Reheating the I/O might damage it. And to remove the extra tin, all clean tip of soldering iron. And remove the extra tin from the pins. If you don't use good quality soldering flux, this step would be very difficult for you. And that is the miracle of a high-quality soldering flux. That allows you to do this easily. I'll do this for another side too. Like the previous side. I spread the tin by dragging soldering iron tip from right to left. And repeat it until I make sure all pins are attached completely. By color change in pins and the pad under them, you can figure out that the tin is stuck. And there is no need to solder again. And I remove the extra tin. And clean the board. And test if all pins are properly attached or not. I cleaned the I/O. Now I'll grab a needle and check if the pins that I soldered are properly attached to PCB or not. I'll drag it on the pin slowly. If a pin gets bent or deflected from the direction, it means that it's not soldered on PCB properly. That's it. As you see, all the pins are properly placed. Don't put too much pressure because PCB pad might get detached. Or tin on the pins might connect together. There are some other components too. like this connector, keyboard, touchpad or Wi-Fi connector, which are attached to board from two sides. Like RAM slot. You can use the method I showed with connectors and change them. Because they are plastic connectors like the one I changed. And they melt by heating too much. Let's change another most common connector. Connector of Asus mini board of hard disk. As you see, middle plastic of the connector is broken, which caused the pins to float in air. As you see, the connector gets crooked. And when male and female pins meet, they don't stick properly. As this is broken, I won't heat it from the bottom. I apply soldering flux on this connector first. And heat it by hot air gun. And remove it from the board. Like this. And exactly like what I did while changing rest of the components. All clean under the pins with desoldering wire. In order to have a smooth surface and to get it ready for placing the new connector. As you see, pad is completely clean and ready to place the new connector. An important thing to keep in mind about hard disk connectors is that you need to solder it on the board in a way that it gets placed in the middle of these pads. Meaning you shouldn't place it too high or too low on the sides. Because if you don't pay attention to the distance, male and female pins wouldn't get connected properly. And they might get damaged or broken when you put mini board on the main board. So make sure to place it exactly in the middle. And then solder it. I'll apply soldering flux. And then place it. As you see, pins are equally distant from two sides of pads. And they are almost in the middle of the pad. As I said, all solder holder pins of the connector first. It doesn't matter if it is crooked. And after soldering one side, all melt the tin. All fix the part that connector gets placed in. As you see, I'm moving it again. And fixate it in its place. Like this. I'll solder the rest of the holder pins to make sure the connector won't move. I'll start from one side. As I said, don't change plastic connector with the method you use for changing IOs. And don't drag the tip of soldering iron in a steady way. Because after tin sticks, you can't heat them again. In order to melt and remove the extra tin. Because if you do, plastic will melt. You need to solder each pin with patience to have a nice and neat result. As you see, I started to solder the pins one by one. I place tip of soldering iron on PCB and the tip of connector pins. so that when tin melts, it sticks to PCB and connector pins. This part is stuck now, there is no problem. I'll explain why. I'll continue the process. I'll remove extra tin of this part. I'll check the pins using a needle just like how I checked I/O. I left a pin loose to show you. Take a look at this pin that is not soldered well. And when I drag a needle, it bends. You shouldn't put too much pressure, so that it stays that way permanently and won't be fixed. Drag the needle gently and detect loose pins and solder them. I'll solder that pin again. I checked the other part with a needle too.
با سوزن تست کردم.
To be sure all the pins were placed properly. I told you these 2 pins are unimportant. Because as you see, these pads are connected to each other on PCB, which means these 2 pins are actually considered one pin. So you don't have to try to separate them from each other. Because they are connected to each other on PCB, and there is no need to separate them. So this was how to change different components of PC devices. Hope you've learned some tips and use them on your daily work. Thanks for watching.